Oh, wait, hold on. You see the 1, 2, 2, 1?
Yeah. No,
You
that
only
wouldn't
need
be
one
yeah, it would
because
only be like
yeah.
mhm.
Mhm. Mhm. Yeah, that's it.
Okay.
Cool. So, and what this helps us to do is work out the coefficients in our expansion. So, for example, to keep it simple, if I had x plus y
Mhm.
to the power of 6, or no, let's go 4. That's going to be 1 x to the 4.
Mhm.
This is the fourth line. 1 x to the 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus 1y to the 4.
Mhm.
So we've got the 14641 and the x parts and the y parts. Notice how you've got x to the 4, then it goes down to x to the 3, then it goes down to x to the 2, then it goes down to the x to the 1, and then there's no x.
Mhm.
And then for the y terms, it starts off with no y's, then it goes to y to the 1, then y to the 2, then y to the 3, then y to the 4.
Mhm.
And also, another thing, if you want to um, have something that you can use to check if you're doing it right, the powers, the groups of powers in each term will always add up to 4. So you've got x to the
Okay.
4, x cubed y to the power of 1, 1 plus 3 gives you 4, x squared y squared, 2 plus 2 gives you 4, x to the 1, y cubed, 1 plus 3 is 4, and you've got y to the 4 where it's 4.
Mhm.
Cool. So we can extend this now to examples like this, and I'm going to keep it with the same power just to show you. So you've got, let's suppose you had 2x plus 5 to the power 4. That would be 1 bracket. Rather than writing x to the power of 4, this time x has been replaced with 2x, so we'd put 2x to the power of 4. And then instead of putting 4x cubed, we'd put 4 and then 2x cubed. And instead of putting y, we're going to put 5.
Okay.
And the next term, do you know what that might be?
So the next would be 6,
Mm-hmm.
and in brackets 2x to the
Yep.
power of 2,
Yep.
then 5 in brackets to the
Mm-hmm.
power of 2.
Yep. Nice. And the next term,
4 brackets 2x
mm-hmm.
5 cubed.
Yes. And the next term,
It would just be 5 to the power of 4.
that's it. So one lot of 5 to the power of 4.
Mhm.
And at this stage, all we have to do is just simplify. So the first term is going to be 2 to the power of 4, which is 16. So 16x to the 4.
Mhm.
Next term, we have 2 cubed, which is 8, times 4 is 32, times 5 is 160. So 160x cubed. Next term, we've got 5 squared, 25, 2 squared is 400, times 6 is 600, x squared. Then we've got 4 by 2 is 8, 125, which is 5 cubed, times that by 8 is 1,000. I really hope my arithmetic is correct here. Yeah. And then you've got 5 to the power of 4, which is 625. For the most part, to be fair, your calculator can do most of the simplification. You can actually input that exactly as it is, obviously without the x, and the calculator will give you the coefficients. But that's pretty much it.
Okay.
Yeah, that's pretty much it for expanding, um, things like that. Okay, so the next kind of thing would be expanding something like this. So 3x minus 2, and I'll still keep it to the power 4. So this catches people trip up when they're first learning it. What I'd recommend is simply rewrite it as 3x plus bracket minus 2, and then from there you can do what you normally do. I'll give you 2 minutes. If you want to write it on paper, you can, just to write down what your expansion would be and a simplified version, and then I'll start going through it as well.
I just do it on the board. Yeah.
Oh, okay, that's cool.
Yeah.
So it's 4. Yep. And then simplifying it, this time it's going to have a mixture of pluses and minuses.
Mm-hmm.
So you've got the, oh, you see where
Is
you've
that
got
right?
3 to the power of 4,
Yeah.
you're doing 3 to the power of 4, not 3 times 4.
Oh, sorry. Yeah.
Yeah.
I almost made a mistake with the other time as well.
Mm-hmm.
3 to the power of 4. Okay.
So I think you went one too far. No, it's two too far. 3 to the power 4
Mm-hmm.
is just 81.
It's just right. I did 27 times 27. Wait. Okay. Okay.
Then we have 3 to the power 3, just 27. Times by 4 is 108. Yes, minus 216 as opposed to
Okay.
206. Then 3 squared is 9. 4 is 36. 36 times 2 is 72 times 3. Yep. And it's plus 216. 8 times 3 is 24 times 4 is 96. Yep. Yeah, minus 96x plus 16. Cool. Okay. And then just one where you've got to do some simplification of powers. What about this? Oh, on the next slide, that is. This time I'm going to write to the power of 5. And I write Pascal's triangle in the bottom left. Wait, that's not enough space. Yeah. Okay, so you've done it with y. And then you're now going to make a substitution. Yes, you made all the correct substitutions. You're trying to fit in that little x minus 1 to the power 5.
Yeah, I just
Yep,
put that bottom.
yep, it's all good.
Would I need to make it so that 10x to the power of minus 1 becomes 1 over 10x?
I think you can leave it in terms of just negative powers. That's fine.
Okay.
Yeah, like you definitely understood the point of the assignment, basically, which is good.
Okay,
Yeah, this is good. Like you're strong. You're solid.
that's good.
It is. Do you want to see what an example of an exam question would look like?
Sure.
This on slide 3
Mhm.
is an example. So first of all, you'll notice that um they don't want you to do the whole expansion.
Mhm.
They're only asking for the first 4 terms. And yes, it does require going to line 7. Now, I've only taught you Pascal's triangle,
Mhm.
but in theory, they could ask you to expand something that goes to, I don't know, to the power of 15.
Okay.
Now, whilst you could write Pascal's triangle all the way to line 15, there is actually a more efficient way, but
Okay.
we'll learn that potentially next lesson.
Okay.
At this stage, I kind of just want you to focus on the expanding and the answering of these kind of questions.
Got
Mhm. Nice.
So when it says the first four terms, it would just be whatever these values are.
Oh, do you know what? You even went further. Did you go up to x to the 4? Oh, okay. Actually, this is an important thing. Right. I kind of missed out another detail. So there was another thing that said in ascending powers of x. So really, you want to start from the lowest powers. You see how you switched it around to ax plus 1?
Okay.
Better to leave it as 1 plus ax.
Okay.
And then you start with 1 to the power of 7 plus 1 to the power of 6 ax plus 1 to the power of 5, and with the other coefficients.
Mm-hmm. And they want me to do these four terms.
Yeah, the first 4 terms. And this is where also not those 4 terms, not those 4 terms. Let me show you on the part A. So you've got 1
Mm-hmm.
to the power of 7
Mm-hmm.
plus 7 times 1 to the power of 6 ax to the power of 1. So that's your second term. Then you've got 21, 1 to the power of 5 ax to the power of 2, and then your next term.
Okay. And that'd be 35, 1 to the power of 4. I'll just
Yep.
write that out.
Oh, do you want to write it? Cool.
Yeah. 35, 1 to the power of 4. And ax to the power of 2.
So I'm going to ask you to do that check where the powers are going up / down,
3.
and if all the powers are adding up to 7.
Yeah.
Yes.
3.
So that's the first 4 terms. So yeah, weirdly enough, that 1,
Mm-hmm.
it counts as a term.
Okay.
And then it's just about simplifying it.
Mm-hmm.
So the final
1.
simplification. Oh yeah. Oh, can you fit it down there? Okay,
Yeah, just about.
cool.
Would it be a squared x squared or just ax squared?
What you said was correct. A squared, x squared,
Okay.
because you're squaring both terms.
Got
Or it's ax times ax.
it. Mm-hmm.
Cool. The second question, or the second part,
Mm-hmm.
is where there's a little bit more, just a little bit more thinking to do. Given that the coefficient of x squared in this expansion is 525, find the possible values of a. So this is where we zoom in on the x squared term,
Okay.
and they've said that the coefficient is equal to 525. So
Mm-hmm.
this is identical to 525 x squared.
Mm-hmm.
So what other information can we deduce from this?
That a squared times 21 gives us 525.
Exactly that.
Okay. So then we can just say, yeah, 21a squared is equal to 525 and find
Mhm.
a from that.
That's it. Mhm. And one other thing as well I'm just going to underline this.
Mm-hmm.
Emphasis on the S, so we want to put plus or minus.
Mm-hmm.
Yes. So yeah, that's a kind of another type of question that you could get.
Mm-hmm.
And you'll notice that the binomial expansion isn't actually so bad. Like, what other terms? Okay. I'll give you another one that's similar. So very often the first part will ask you to expand something, the first whatever terms, and then next part will be like a slightly harder version.
Mm-hmm.
So remember, um, you're doing it the way round that the question's written it.
Okay.
So rather than having the x's of the high powers, start with the 2 of the high power.
Okay, I'm just copying from the last slide. After writing out Pascal's triangle, first 4 times.
Oh, I can do Pascal's triangle. I can write that out.
Okay.
Yeah. Nice. So with this, you're probably better off just taking the coefficients. So the coefficient of x squared was 672k squared.
Mhm.
And then you can write that without the x squared. And then the coefficient of x was 448k. So you'd put
6
6.
times the. Okay, I see.
Mm-hmm.
Okay. Right. Okay.
Mm-hmm. Did that say that k squared equals 2/3 k?
Yeah.
If that's the case, then you would have to make it all equal to 0 because it's a quadratic. Or, to be fair, would you have to? Actually, no, it's just find the value of k. No, it's fine.
Okay.
Yeah, I misread. I was there thinking you've gotten rid of a solution, but actually, no.
Mhm.
The question says find the value of k. And also, yeah, it wouldn't make too much sense for k to be 0.
Mhm.
Yeah, you're good. Nice.
Okay.
Um, let's find another similar-ish question. Oh, wait, hold on. I just realized something. You see how you put, yeah, I think you forgot the 6 on this line,
Okay.
as in 6 times 448, okay? Because you notice the question says, given that the
Okay.
coefficient of x squared is 6 times.
Yeah. Okay. So the 6 would go like that.
Times, yeah.
Okay.
It basically just makes the numerator 6 times bigger,
Mhm.
which makes the answer for k 6 times bigger. Yes, that's it.
Okay.
Nice. Yeah, you pretty much, the questions don't really get so much more difficult. There are some questions where they will ask you to make approximations. Yes. I'll show you how to answer those questions.
Mhm.
So I'll let you do the first part, which is again standard. You'll see this very, very, very frequently. Oops. Oh, I didn't. Sorry, did I say it's slide 5?
Yeah, I'm just looking at it.
Okay, cool.
Might just continue Pascal's triangle on the last slide and use that instead of writing
Oh,
the whole thing out again.
yes, yes, go for it. Of course. So you're continuing it.
Mhm.
I keep forgetting that we haven't learned the more efficient way of generating the terms. But next session.
Mhm.
Yeah, next session with something later to come. It won't take too much work to learn how to generate those terms.
Mhm.
You'll notice as well that you won't have to generate all the time.
I only need the first three.
Yeah. I was looking at you writing. I was like, I wonder if you'll realize that. You know what? Let me stop him now. But to be honest, I don't know if you notice as well. Pascal's triangle symmetrical,
Yeah, yeah.
so hopefully you weren't figuring out the rest of the terms after. Yeah, I feel like well, there were errors made, but it's fine. You won't actually need those terms.
Okay.
Yeah, 110, 45. Yes. So 110. Yeah. So with the second part now, use your expansion to estimate the value of 1 plus. I'm interested to know what you're right. Yeah. Hey. Oh my gosh. Yes. That's it. You got it.
Okay. That's good.
Precisely that. Yeah. That's really what you call putting two and two together. Yes. Yes.
So I have the value of x, but it wants me to find what the expansion would be.
Basically, I mean, well, you've already got the expansion.
Yeah.
Um, Now what you've got to do is substitute that value of x
hmm
into um your expansion. So instead
So
of putting 1 plus 5x plus 45x squared over 4,
mhm.
you'd replace x with 0.01.
Okay.
Mhm. So you see in your expansion
hmm
how your simplified version was this.
Okay. So one would just become 0.01.
No, one just stays as 1.
Says one. Oh, right, because the one
It's
here.
the x is that you're replacing
Okay.
with. Yeah, like you're literally looking at your answer here.
hmm
That's it.
Okay.
And it becomes a calculator thing.
hmm
Yeah. Yeah, like honestly, you've basically nailed the topic of binomial expansion.
Okay.
Um,